Okay, back for part 2. This should only take about 10 minutes for absolute value inequalities. Now briefly here, when you are solving an equality with absolute value, for instance, if you had absolute value of x equals 5, what would your solution be? Think about it in terms of the number line. This is saying that the distance from 0 to the number, from 0 away from 0 is 5 units away. So we're 5 units away on the right-hand side, on the positive side, and we are 5 units away from the left-hand side, the negative side. So your answer here would be x equals positive 5 and negative 5. So what happens when we have inequalities, for instance, what if we had the absolute value of x is less than or equal to 5? That means that distance away from 0 is less than or equal to 5. So on the number line, once again, our boundary points, we're back to the boundary points, would be positive 5 and negative 5. But if your absolute value is less than, then it's going to include all the values between positive 5 and negative 5. And then what would happen if it was absolute value greater than or equal to 5, or just greater than 5? Same idea here. Look at it visually. Here are our boundary points once again, 5 and negative 5. This time the distance is greater than 5, so we would shade to the right of 5 and to the left of negative 5. So this is similar to what we just got finished doing with the compound inequalities, the quadratic ones. You are going to have to test some regions. You can test regions if you want to, but if you want to just remember that when the absolute value is less than, your shading is going to be in between. Again, here my solution set would be negative 5 to 5. And if the absolute value is greater than the number, then the solution set's going to go from negative infinity to negative 5, or 5 to infinity. Okay, so if you keep that in mind, this should not give you that much trouble. I only have 2 examples here. First example says the absolute value of x minus 5 is less than or equal to 3. Now, if you want to keep this in mind also as well, this shading again should be in between, but this time we're looking at it as if you want to set up boundary points, you can work it this way. You can say x minus 5 is less than or equal to 3, and because the shading is going to be less than, it's in between, x minus 5. Now what happens when we have to set it equal to negative 3? Our inequality sign flips and it'll become x minus 5 greater than or equal to negative 3. A shortcut is just to do this. Take away the absolute value and put the x minus 5 between 3 and negative 3, those 2 boundary points. Solve the inequality, the compound inequality, and then we have our solution, which would be x is going to be now between 8, less than or equal to 8, and 2. So my solution set here would be bracket 2 to 8. And again, if you want to sketch the number line for that, feel free to do so. Oh, it does say to sketch this solution set. Graph the solution set. You might have to do that in homework. Here's my 0, here's my 2, here's my 8. Let's just validate this as well. The shading is going to be in between those. Okay. And then again, the absolute x minus 5, if we pick values in between there, let's pick x equals 6. Okay. Is 6 minus 5 absolute value less than or equal to 3? Of course it is. Okay. If we pick 0, 0 minus 5, the absolute value of negative 5 is not less than or equal to 3. So you can just double check that. Okay, last example, we have one going the other way. We have a little bit of solving to do first here. So we've got the opposite of absolute value of x, 2x plus 4 is less than negative 7. And then we flip the sign because we have a negative in front of the absolute value, make it positive. So absolute value of 2x plus 4 is greater than 7. This time it's greater than, so the shading is going to be on the outside. So we would write down 2x plus 4 is greater than 7, or 2x plus 4 is less than negative 7. Keep in mind you're not using absolute value in this spot. We took that away. We know visually what it should look like. So we're left with 2x is greater than 3. So x is going to be greater than 3/2. Or 2x is going to be less than negative 11. X is less than negative 11/2. Let's see what that looks like on our number line. So we've got 3/2 over here, negative 11/2 here. Open interval at each of those, greater than 3/2, less than negative 11/2. In the interval notation, we're going from negative infinity to negative 11/2, or 3/2, positive 3/2 to positive infinity. So it would be helpful if you remembered the specific rules for the interval. Absolute value less than the value, shade in between, and absolute value greater than the value, or you shade on the outskirts. Sometimes you will have no solution, sometimes you will have all real solutions. I think we'll just stick with these basic ones for this section since we've covered so much material in this section. Okay?